Dear students, in my previous class I have discussed the Gauss elimination process to solve a system of equations, and that system of equations was non-homogeneous. Today the most interesting thing is we will solve the system of homogeneous equations. For your simplicity, I will consider a very simple example and I will solve that examples. After that, I will tell you the general theory behind it. Okay, so let us see one problem. Solve x plus 2y plus 3z is equal to 0. 2x plus 4y plus 6z is equal to 0. X plus y plus z is equal to 0. Okay, so this is a system of homogeneous equations because all the elements in the right hand side are 0. We will solve this system of equations just like the Gauss elimination process what already we have discussed earlier. 2, 3, 2, 4, 6, 1, 1, 1. This is the coefficient matrix. And the unknown vector is x, y, z. And the right hand side b is equal to 0, 0, 0. As b is 0, we say this is a homogeneous system of equations. So that is ax is equal to 0. So that is why it is called homogeneous system of equations. This is a homogeneous system of equations. Now you see how I am solving. Step 1. We will consider it is a corresponding augmented matrix. So 1, 2, 3, 0, 2, 4, 6, 0, 1, 1, 1, 0. So this is our step 1, that is the augmented matrix. Okay, so that gives step 2. Step 2, that gives, this is step 2. We do the row operations on this to make these two elements 0 by considering this as the pivot. So what it gives? So row 1 will not be changed, that is 1, 2, 3, 0. And row 2, row 3 will be changed, this will be 0, this will be 0. Then we have to find out by which row operations we are making this one as 0 and this as 0. So row 2 is changed. How? Row 2, this is 2 minus 2 row 1. And row 3 is changed. How? This is 1. So that is row 3 minus row 1. So this is 4. We have multiplied 2. 4 minus 2 into 2. That is also 0. 6 minus 2 into this. That is also 0. That is 0. Here 1 minus 1, 0. 1 minus 2, that is minus 1. 1 minus 3, that is minus 3. And this is 0. Okay. So now we rewrite this, that is step 3. Step 3, we write the 0 row to the last. That is 1, 2, 3, 0, 0, minus 1, minus 3, 0, 0, 0, 0, 0. Just we exchange row 2 and row 3. Now we rewrite this matrix again in form of equation. That is x, that is step 4, x plus 2y plus 3z is equal to 0 and minus y minus 3z is equal to 0. Now this is the most crucial and important steps which will give us the idea to find the solution. Okay, see, in Gauss elimination we have discussed that if the number of non-zero rows is less than number of unknowns, then that will give us the infinite solution. Here only difference is the same thing occurs, number of two non-zero rows and number of unknowns are 3, but the difference is right side is 0, right? So how we will solve it? Step 5. Actually here there are two variables, so we have to consider any one variable as a parameter by our choice. So let z is equal to t we assume. Okay, if z is equal to t we assume, then what happens? Minus y is equal to 3z implies minus y is equal to 3t implies y is equal to minus 3t. So we are able to write both z and y in terms of t. Then come to the first equation. Now put z and y in first equation, that is x plus 2y plus 3z is equal to 0. That implies x plus 2, what is y? Y is minus 3t plus 3, what is z? Z is t, that equal to 0. That implies x minus 60 plus 3t is equal to 0, implies x is equal to 3t. Okay, now step 6. Step 6, actually the capital X, that is x, y, z is our solution. But we have found out x, y, z in terms of t. What is x? X is 3t. What is y? Y is minus 3t. What is z? Z is t. So we have found out x, y, z in terms of t. That we can write it as t 3 minus 3 and 1. Okay. So that indicates for different value of t we get different vectors or different solutions which will satisfy these equations. Okay. If we consider t as 1, then 3 minus 3 1 is a solution. If we consider t as 2, then 6 minus 6 2 as a solution. So like that we will have infinite solutions for this system of equations. Now the conclusion. The most important thing, conclusion. The case is where we get these infinite solutions and where we get a very trivial solutions, that is all x, y, z is. Initially we have considered the equation x plus 2y plus 3z is equal to 0, 2x plus 4y plus 6z is equal to 0, and x plus y plus z is equal to 0. Okay, this was our system, and from that we have considered the matrix 1 2 3 2 4 6 and 1 1 1. Its corresponding matrix was 1 2 3 2 4 6 1 1 1. This was the corresponding coefficient matrix. Okay, from this coefficient matrix we will have the conclusion. That is the most interesting, important and tricky things which will be very important for all your exams, not only for your class exam or university exam, it is also important for GATE exam or any competitive exams. Okay, if determinant A, this is it's a determinant value, determinant A is not equal to 0, is not equal to 0. This is not equal to 0 means by row operation this 3 number of rows cannot be reduced to less number of non-zero rows. That indicates determinant A is not equal to 0. That means by row reduction process, by row reduction the number of rows cannot reduce to non-zero rows. That said, determinant is not equal to 0. If that happens, that implies only one solution exists, that is trivial solution, that is x is equal to y is equal to z is equal to 0. Very simple. Okay. If we are, again I am repeating, if we are not able to reduce this determinant or a matrix to a row reduced form, means its determinant value is not 0, then the system of equations will have no solutions, only one solution exists, that is the trivial solution, and that is x, y, z equal to 0. Okay, that is conclusion 1. Conclusion 2. Conclusion 2. If after row reduction we find less number of non-zero rows, then number of unknowns, or in other words, determinant A is equal to 0. Here determinant A is not equal to 0, here determinant A equal to 0. Determinant A equal to 0 means singular. That implies system of homogeneous equation will have infinite solution. Okay, so this is the idea that how we solve homogeneous system of equations.